So the area of the rectangular region pictured, so the area, remember, of a rectangle is equal to the length times the width. If we can find L and W, or something about that product, we will have sufficiency. Statement 1 gives us L plus W equals 9. There's, as tempting as that would be, this ends up being a single linear equation for two variables, because there's no way that we can actually get from L plus W to L times W through algebraic trickery. So we can't get from here to here without some additional information. So statement 1 on its own will be insufficient. It's not going to be A or D. Statement 2 tells us x squared equals 45. And we can use the Pythagorean theorem here since it's a rectangle. That's a right triangle. So L squared plus W squared will equal x squared. So we know that L squared plus W squared equals 45. But there's more than one value that gives us two numbers whose squares add up to 45, including things that the length and the width could themselves be square roots. So it could be the square root of 42 and the square root of 2, for example, 3. Square root of 42 and the square root of 3. We don't know yet, and so statement 2 is not enough information, so we cross off B. In conjunction, though, we have a lot more information. We have two numbers whose squares add up to 45, and those numbers themselves add up to 9. Let's come up with a couple examples. So 4 and 5, L squared would be 16. I guess, technically W should be the smaller of the two, but never mind. 4 squared would be 16. 5 squared would be 25. That gets us up to 41. So we're pretty close because we need it to be equal to 45. Let's try our next pair of numbers that equal 9, 3 and 6. 3 squared is 9. 6 squared is 36. 36 and 9 equals 45. So our sides are 3 and 6 respectively. Between the two, the statements are sufficient. So enter choice C is the correct answer.